Okay, hello everyone. Good morning. All right. So today we will continue on damping and resonance. Right. So before that, can you open this website? Okay. Then I will give you the code. Okay, for you to join. Okay, for those who use phone, right? I will give you the QR code. Then you can scan the code and enter the class. Okay. Wait for a moment. Okay, so this is the class code. Okay, and you can scan the code. Okay, if you're using a handphone, you can just use the code there. And for those who have a laptop or using a PC, you can open the website and put the code also. So I put the code in the chat. You can who's still not here?
Yeah,
Can you
sure.
please check?
Tava,
And Tava
Tava
only.
and Rindia.
Tava and India. Okay, thank you. Okay, so wait for others. Okay. To join. So actually we have 14 people, so means 6 more. Do you have any problem to log in the website or use the code? Okay, 3 more. You cannot use the code.
Teacher, my internet a bit slow.
Oh, okay.
Okay.
Okay. So Janet and Wilken, think 2 more people only, right? Okay, and India. Okay, India, please. I have 2 names. Okay, so I will remove one of it. Okay, so Rindia, please goes to this website, okay, and then please key in the code here that I give in the chat room. Yeah. So one more Tava only. 1, 2, 3, 12. So Janet 13. Who else still didn't join? Eugene. Okay, Ria. Okay, Tava. Please, maybe you can use your phone first, and then later you can, when your laptop already okay, then you can use your laptop. Okay, Tava, please open the website and key in the code there. So all already here. It's supposed to be 16. We can. Who else who's still not here? Janet, Tava, and another one who?
Hey Raja. Er,
Mm, mm, what do you mean? Asher, right? Yeah. So now we only wait for Tava, then we start our class. Okay. Alright. So let's move on to the next slide. Okay, damping and resonance. So a baby is in a cradle, okay? So his mother swings the cradle until she falls asleep. So while the cradle swing, okay, with decreasing amplitude and stop at last, okay. So what makes the cradle stop oscillate after his mother stops swinging? So after you learn about damping, okay, you'll be able to answer this question. So why the amplitude, right? Why the amplitude of the cradle, okay, is decreasing, and why, okay, at the some time after that it will stop, okay. Okay, can you please answer this question? Okay, so what can you say about the amplitude, and what can you do to maintain or increase the amplitude? You can type your answer and submit. So what can you say about the amplitude of the swing, right? And what can you do to maintain or increase the amplitude? Can you type the facts? Okay, so I see already one of you submit the question. Sorry, submit the answer. Okay, four. Hi. So 12 more.
Teacher, what if I don't know?
What?
What if I don't know?
You don't what? You
What
don't
if I
know.
don't
Okay.
know?
If you don't know, you just leave it empty.
And do I submit or
Yeah, submit.
okay?
Mm. Okay. Nine more. Sorry. Eight more. Okay. Six more. So I will check who still didn't. Nirupa, Rindya, Janet, Asha, and you have two names, Janet. Or the one you use a laptop, another one you use a PC.
Yeah.
Okay. So Nirupa and Rindya. Rindya. Okay. So let's check the answer. Right, so some of you say it will move back and forth and the amplitude will decrease. Okay, over time to maintain the same amplitude, the person have to push the swing constantly. Okay, correct, right? So the amplitude will decrease. Okay, but if you want to make it the swing, okay, keep swing. Okay, you have to give a force to it. So decrease, okay, when the fast straighten, when the back shorten the leg. Okay, this one is not the impulsive force, okay. So by pushing the swing with a greater force, yes, okay. The this one is for the second question, right? Okay, we decrease, we have to swing until yes, the amplitude is not equal. Okay, the amplitude is actually decreased, push greater with the greater force, correct. The amplitude of the height of the rope attached to the swing, okay, to this one is wrong. To increase it, we have to push it with higher force. Yes, correct. Okay, so Eugene, alright, so no answer. Abi also no answer. Sharanya, swing will oscillate with a smaller and smaller amplitude, means it will decrease. Okay, changing the frequency require vibrating object travel with more speed to wave. Changing the frequency, you means you oscillate it more. Okay, so requires that the vibrating object travel with more speed to travel. I'm not sure what does this mean. Okay, if you change the frequency, to me, if you want to change the frequency, you have to vibrate the object with more speed, is it? Okay, but this one, for the damping oscillation, okay, the frequency is actually constant. Okay, for damping oscillation, the frequency is constant. The only one change is actually the amplitude. Okay, so we will see about that. Okay, so let's continue. Okay, so here, right? Okay, remember we learned before this, right, about the amplitude. So the amplitude is actually from the equilibrium position to the maximum displacement. So let's say the boy oscillate until here, means the amplitude is from equilibrium position until here. So that's it called as the amplitude. So you can see here, right, the amplitude is become decreasing, right? Sorry, the amplitude is become decreasing. Okay, and how to maintain or increase the amplitude? So mean you have to push, okay, the swing, okay, harder, or you can say you give more force to the when you give more force when you want to push the swing. So it will increase the amplitude. Okay, so that's the answer. Okay, so let's move on to the next part. Okay, so you can see here, right? When the pendulum, okay, when the pendulum start oscillate, right? So when it start oscillate, okay, because it start from here, means the amplitude is the maximum. Okay, because it start oscillate from here, so means the amplitude is maximum. Okay, and then after that it go back to the equilibrium position here. Okay, so this is the equilibrium position, so it will become zero. Okay, and then after that you will oscillate until here, right? So means it will come here, it will go here. Okay, and then after that it will go back to the equilibrium position, so it will be here. Okay, so after that it makes it go back to here, so that you can see the amplitude already decrease. Okay, so that's why even it goes to maximum, it goes to, it still have the amplitude, but the amplitude is already decreasing because the maximum displacement already decreased. Okay, then it will goes until it stop, until it become zero. So this is called as the damping oscillation. Okay, so means the swing, okay, the pendulum will swing until it stop oscillate. All right, and you can see the amplitude is decreasing. So this is the graph of damping oscillation. You can see the height of the amplitude is decreasing. Okay, so this is called as the damping oscillation. So just now Tava answered about the frequency, right? So what is the frequency? Frequency is actually 1 over t. So t is the period, right? So if this is the amplitude against time. Okay, so amplitude against time, or actually it's displacement. Okay, displacement against time. So the displacement here, if you want to get the period, you have to take two semicircle, right? Okay, so this is half, this is one semicircle, then this is another half. So this is called as the period. This is equal as 1t, one period. Okay, then let's see, we compare about the distance between two period. Okay, so another one period is from here to here, right? So this one is another t. So can you see the distance, right? Is same. Okay, let's say if you let's say if you give a value, okay, to the axis here, you can see the period is same. So means when the period is same, the frequency also should be same. So actually in the damping oscillation, the only magnitude or the only physical quantity that are changing is amplitude, but but not frequency. Frequency will be constant, or the period will be constant. Okay, so please remember this one. Okay, on the damping oscillation, only the amplitude change, only the amplitude decrease, but the period or the frequency will be constant. Right? So please remember that one. So there will be no change in frequency here. Okay, why you can see the graph here. Okay, if you compare the distance between two period here, you can see the distance is same. Okay, so it does mean that the period is same here. So the frequency also should be same. The only thing that change is amplitude, or sometimes they put as energy. Okay, so sometimes they didn't put the amplitude there, they put energy. So actually energy is also same as the amplitude. Okay, so you can see the distance now become shorter, so means the amplitude also decrease. Okay, until it stop oscillate. Okay, observe the motion of the pendulum. What can you say about the amplitude? Okay, so at the start, the pendulum oscillate with maximum amplitude. So the amplitude of the oscillation decreases with the time, and finally it will stop. Okay, so what caused the decrease of the amplitude? Okay, so this one is caused by the air friction. Okay, so mean there will be energy loss, okay, to overcome the air friction. So that's why the amplitude will be decreased. And I already told you just now, amplitude is the energy. Okay, so the energy will be decreased because of the, it needs to overcome the air friction. Okay, so when the pendulum oscillate, it has an energy, alright, and energy is used to overcome air friction. So as time passes, more energy of the pendulum is being used to overcome the air friction, right? And this causes the energy of the pendulum to decrease, the amplitude becomes smaller, okay, and the pendulum is said to experience damping. So this is actually damping oscillation. Okay, when something is oscillate, okay, and they experience the decrease in amplitude and it will stop. Right, and you have to remember the shape of the graph, okay, because sometimes they ask you to draw. Okay, they ask you to draw the damping oscillation graph. Okay, and one more thing you have to know, either that the amplitude is decreasing, you have, when you draw, you have to make sure that the t here is same. It means the length, okay, the length of the each semicircle is same. Okay, so because the period is not changing, as I told you before, and also the frequency is not changed, right? So when you draw the graph, you have to make sure the amplitude is decreased, and also the semicircle between two semicircles must be same, right? So this is called as the damping oscillation, right? So amplitude, remember, represent the energy. So when it oscillate more, there will be more loss of energy because it need to overcome the air friction. Then when there is no more energy, okay, because already lost to the surrounding, right? Okay, so it will become decrease, then there will be no energy more to overcome the air friction. So it will be stopped, right? Okay. Can you give me the answer? Oh my god, I can't answer. No, where's the picture? You can refer in the
Picture number two also. Sorry, number three also.
number three.
Yeah, it says state the relationship between amplitude of the vibration with time.
Means there is a slide missing here, is it?
Yeah.
Oh, okay, okay. Wait for a moment. I think we start until. Can you give me for a moment? I need to see my slide first. Hmm. Yes, I think I already. Okay. Okay. Oh, okay. All right. Okay. You can give the answer. For number two, you put just number two. What's the answer? Number three, what's the answer? Number four, what's the answer? So this one is actually if you see the diagram here, this is actually the initial experiment. Okay, you put the plasticine, okay, on the hacksaw blade. The second experiment that we're supposed to do. Then suddenly MCQ, right? Okay, five students already submit their answers here. It's okay if you don't know. Okay, you can just leave it empty. Okay, or maybe you know like answer like two or three questions. Okay, you can just submit. Okay, but you have to put the number of the questions so it's easy for me, right, to check. Okay, I give 1 more minute, then we discuss. Okay. Okay, so I stop. Weekend, are you okay?
Yes.
This one is not actually you have to name, is it?
Two names. Yeah.
Yeah. Okay, okay. Weekend and Janet. So only Sharanya. Where Sharanya? Okay. Right, so let's see your answer.
Teacher, you're not presenting.
Oh, alright. Okay. Okay, so this is your answer. Okay, amplitude decrease. The longer the time, the shorter the amplitude of the vibration. Alright, the energy has been used to overcome the air friction. Okay, it will decrease, right, and it will stop. Okay, so this one actually number one, is it? And number two, amplitude decreases, amplitude when the time increases.
Teacher,
Alright.
number one, they just tell that
Order,
the
oh yeah, that.
system to position X and Y.
Okay. Number two, amplitude decreases. Yes, correct. Presence of air friction. The energy is lost time to time to overcome the air friction. Stop, oscillate, and came open rest. Okay, the amplitude decreases because the energy will be lost. It stopped. Okay, it will come to rest. It will stop. It eventually. Okay, so most of you got move slow. Okay. Krisha, when it says, okay, never mind. I will discuss about this question first. Alright, so here it said, right, it asks you to observe the amplitude, okay, when the time increases. So the amplitude should be decreased. Okay, so that's the answer. And then it asks you state a relationship between the amplitude of the vibration with time. So when the time increase, okay, the longer time means the amplitude also will be decreased. Okay, when the time increase, right, the amplitude decrease. And give one reason why the amplitude decrease. So this one is actually the energy loss due to the air friction, right? So the energy loss due to air friction. Okay, what happened to the energy possessed, okay, by the plasticine and the blade? Okay, so the energy will decrease because I already told you actually the amplitude they represent the energy. Okay, and what happened to the oscillation of the blade after a long time? So after the long time, of course, okay, the blade will be stop oscillate. So the answer should be stop. Right, so let's check your answer. This one I already checked, correct. Okay, and this one correct. Okay, will be lost, will be decrease, eventually stop, right? Then the time increase, amplitude decrease, the higher the lower energy it decrease, eventually stop. Okay, it will come to rest. Okay, so tawa actually it will stop, right? Directly proportional. The amplitude directly proportional to the time. What does it mean by directly proportional? So directly proportional means when the time increase, the amplitude also increase, right? So it's wrong. It should be inversely proportional. Okay, so that's why I didn't prefer you answer in the graph, like the relationship of the graph. Okay, so increase, no, inversely proportional, not increasing. Inversely proportional, this one. Okay, this one directly proportional when the time increase, amplitude also increase. No, right, the amplitude will be decreased. Okay, the higher the amplitude, the longer the time taken. No. Alright, you see the graph, Tava. The graph is the amplitude becomes smaller, right? So this one, the amplitude, you can see the amplitude is become decreased. Okay, so the longer the time taken, so this is actually the time, right? So when the time increase, the amplitude will be decreased and it will not move slow. So after some time it will stop because all the energy already been used up to overcome the air friction, right? Okay. Decrease kinetic energy changes, no. No oscillation or stop. Okay, correct. Okay, Eugene, they are not asking you to find one complete oscillation. Okay, decreases as the time increase inversely. Yes, very good. Yes, very good, very good. Okay, so next one, decrease, decrease, decrease energy loss. It takes longer to complete one oscillation. Actually, it will be stopped. Okay, decrease, decrease, decrease. Stop. Right. Okay. Okay, so let's move on to the next one. So what is actually the meaning of damping? So damping is the decrease in amplitude, okay, of an oscillating system when energy is drained out as heat. Okay, when its energy is drained out as heat. Okay. Okay, damping is the decrease in amplitude of an oscillating system when its energy is drained out as heat. Why heat? Because you know the frictional force that produce the heat. Okay, so what type of energy produced due to the damping? Okay, is actually the heat energy. So how do you overcome the damping effect of the oscillation? Okay, so you need to constantly apply the force to the blade. Okay, you mean you have to give the force, okay, so it can oscillate, okay, all the time. And then you have to sketch a displacement time graph to show the damping process. So this is actually the damping graph. Okay, the damping graph. So this one you need to remember how to draw. Okay, so this one. All right. So there are two types of damping. Okay, the external damping and also the internal damping. Okay, so we already learned that actually why does the amplitude decreases? The amplitude decrease. So the amplitude decrease, okay, caused by the loss of energy, right? The loss of energy to the surrounding to overcome the air friction. Okay, so there are the two type of damping. There is the external damping. Okay, means the energy loss due to the external, okay, the external conditions. So let's say from the air friction, okay, to the from the surrounding. So that is called the external. Okay, so the oscillating system lost energy to overcome friction or air friction. So that's come from the surrounding. So that's why we call it external. Okay, external damping. And another one is the internal damping. Okay, so the internal damping means it comes from the internal. Okay, it come from the inside. So they say this one is come from the stretching and the vibrating of the particle in the system. So you know when the when the object oscillate, right? So when it oscillate, it will cause the stretching and also the compression, okay, for the vibrating particles. Okay, so they need an energy. Okay, they need energy for the compress and also for the stretching. So that's why, okay, so that's why the energy loss, okay, because they need in for the internal system, they need for the stretching and also for the compression. Okay, but and another one is let's say from the external damping. So the external damping is actually used to overcome the air friction. Okay, it may come from the surrounding, right? So there are two types of the damping. First one is come from the factor that come from the outside. Okay, and the second part is come from the inside of the system. So come from the outside is called as the external damping, and come from inside of the system we call it as the internal damping. Okay, so come from the external damping, okay, is actually from the air friction, okay, from the surrounding, while the internal damping come from the system itself, from the vibration or the compression or the stretching, because we know all that needs energy. Okay, so they will use the energy to overcome this internal and also the external damping. Then after that, the energy will be lost. Okay, and after some time, okay, after some time there is be no more energy left, so it will stop. Okay, so are you clear? Do you have any question about damping? Do you have any question about damping?
No, sir.
No. Okay, so are you clear? Any question you want to ask before I move on to the next one? previous slide, which one? This one or this one? Is it? Saja? Yes. You want to copy it first, is it? Done. Alright. Don't worry. After this, I will save all in PDF. Okay. Then I will put in your class group. So if you cannot, you cannot copy. Okay, because not you don't have time to copy. So you can see that in the PDF. Okay, so actually damping is the reduction and in amplitude in an oscillating system due to the loss of energy. So why does the damping occur? Because there is a loss of energy, right? There is loss of energy to the surrounding. Okay, so during damping, the oscillating frequency remains constant while the oscillating amplitude decrease. So for this one, we already discussed. Okay, so as I told you, okay, only the amplitude that change, but the period and the frequency is not changing. Okay. Okay, so the effect of damping can be overcome by applying a periodic, okay, external force on the oscillating system. So mean you have to give force to the system so it can be oscillate. So the external force transfer energy to the oscillating system to replace the lost energy. So every time that we give another force, okay, a new force to it, it will replace the energy that being lost to the surrounding. Right, and the periodic external force transfer energy into the oscillating system to replace the energy loss. So the system is said to be in a force oscillation. Okay, so the periodic external force transfer energy. So every time you give a force to the system, all right, it will keep oscillate, right? So the system is set, okay, is set in the force oscillation, means you give force to it, right, to make sure it keep oscillate. Okay, so at that time we said that the system is said to be in force oscillation because you keep giving the force to the oscillation, so it will keep oscillate. All right. I don't know. Actually, I already okay. Wait for a moment. I already removed that one actually. Okay. Wait for a moment. Okay. Okay. So let's try to answer this one. So it said a mother puts her baby to sleep in a sarong cradle. Okay. So she needs to continuously move the sarong cradle up and down. Okay, what happened to the sarung cradle? Okay, when the mother stopped moving the cradle up and down. Okay, I already give the answer. Farah. Okay, 4, 5. Ten. Okay, I give one more minutes, then we discuss the answer. Harish, Kirtiga, Krisha, Tava, Nirupa. Okay, Tava. Okay, so let's discuss the answer. Okay, right. So before that, we discuss, right, the question first. Okay, so here it said what happened to the sarung cradle when the mother stop moving the cradle ups and down. So of course the amplitude will be decreased. Okay, so the amplitude will be decreased, amplitude decrease. Okay, and after some time it will stop. So suggest a reason for the movement of the sarong cradle discussed, okay, in A. So this one is actually the damping, okay, damping, okay, damping oscillation. Okay, and what must you do if you want to help the mother to maintain the movement of the cradle? So you have to give the external force. Okay, you have to give the external force to the cradle. So it will move, it will oscillate, okay, without stop. And this one you have to explain your answer. Okay, so this one remember just now, right? You already know the energy is lost to the air, to the due to the air friction. So whenever we give a force to the system, okay, it will be replaced. It replace the energy that lost to the due to the air friction. Okay, so that's why it will keep the cradle, okay, to move. Alright, so this one is actually the external force. The external force, okay, is used to replace, okay, the energy loss due to air friction. Okay, so that's the answer. Okay, so the external force is used to replace the energy lost due to air friction. Right, so let's check your answer. It will stop oscillating. Yeah, but you have to mention about the amplitude. Okay, it will still move but get slower. Yes. The word slower is not accurate because we know here, right? The amplitude is decreasing. So you have to mention about the amplitude because this is a damping oscillation. So whatever about damping oscillation, you have to describe about the amplitude. Okay, because the amplitude decreasing, no, move at the same speed, no. Okay, so it will stop. Okay, this one also you have to put amplitude decrease then stop. Okay, due to the compression of the sarong. Okay, don't know. Okay, Rashmi, no answer. It oscillates slow and stop. It is because energy is lost to overcome the air friction. Yes. Make the size of the sarong cradle bigger. So if you make the size of the sarong cradle bigger means you increase the mass. You increase the mass, so you will need more. There will be no more energy lost to the surrounding, right? Okay. And also it's hard for you. You have to give more force. Okay, you have to give more force. Okay, so this one is no. This one is not about the inertia. This is actually about damping. Okay, more force required. Okay, it will slowly come to rest. It will slowly come to rest. Okay, you didn't mention about the amplitude because there is no energy added. The amplitude slowly decreases. And no. Okay, a strong cradle will continue moving slower, slower. Okay, this one, like I said, you must mention the word amplitude. Amplitude is decreasing, move the cradle with the bird with strong force. Okay, just say use a strong force or use the higher force, okay, to move it. Okay, it's because the amplitude will higher, take a longer time. Okay, and the amplitude of the sarong decreases. Okay, this one good answer. Due to the, yes, she continue move. Um, okay. You said you continuously move. Okay, so please use physics quantity, like yeah, he needs to continuously move. So means you have to give force to it, right? So means you have to mention the word force. Okay, oscillate for a while and stop. Okay, no mention about the amplitude. Okay, the energy loss, yes, constantly move the cradle. Okay, so if me, I, like, if you, let's say, if you want to you want to answer like this type of question. Okay, they ask you to explain. Okay, if you need you um I think it's better for you, okay, to use the physics quantity. Let's say just now, like you said, it moves slowly, right? So actually, it describe about what, about the amplitude. That's the main thing that we learn about the damping oscillation. Okay, why damping occur? Because damping is a decreasing in amplitude. So you have to mention the word amplitude, or you mention the word energy. Okay. Hmm. Hmm. Constantly apply energy to the surround cradle. Okay. Energy, energy. You apply force, right? You're not apply energy, you apply force. Okay, and force will become the energy. Yeah, good, Asha. Mm, no, no. This one you mean you give a force to it, right? To apply a force, not to apply the energy. Stop. Okay. No, move the cradle up and down. So this one also false. Okay, the amplitude will decrease. That's an yes. Okay. So never mind. You move slowly and see, and no amplitude, energy is lost, the motion decrease, friction, moving higher force. Okay. Displacement increase. So this one you have to say it replace the energy. It will continuously move. No. Okay, the amplitude is decreased. Alright, so that's your answer. Okay, so never mind. So can you understand about this, about damping? I notice you understand but you don't know how to answer because I think my Wi-Fi is low. Because I don't answer but then submit nothing. Okay. Understand, and when you answer the question is very different thing, right? So never mind. So maybe after this, okay, our next class tomorrow, I will prepare a quiz for you. Okay, I will prepare a quiz for you for damping oscillation. So let's see if you can answer it or not. Okay. So I see you tomorrow. Okay. So
Teacher,
take care, class. Yes.
so tomorrow is presentation or continue with today's lesson?
Okay, because 1 hour and half, right?
Yeah,
So half an hour is for you to present. Okay, means like 6 or 5 people will present, and another 1 hour is class. Okay, and I would, okay, is it okay?
alright.
And I will just choose random people. Okay, we will play wheel of names. So, you have to be prepared. Okay, so only 4 people yet, right? You didn't submit the project. I think 4. Later weekend, can you please update for me?
Ah, okay.
Okay, so take care, class. Okay, I see you on tomorrow. So prepare for your presentation.
Alright.
Okay, bye bye.
Bye, teacher.
Bye.
Thank you,
All right,
teacher.
welcome.
Thank
Bye.
you, teacher.
Bye.
Thank you, teacher.
Bye.
Thank you, teacher.